So now that we know a little bit about classes, we can talk about another powerful tool in Python, which is inheritance. Now, inheritance lets you create a new class from an existing class as a foundation. So the new class will inherit the data and methods from the existing class. The new class is called the child class. It's derived from a parent class, which can also be called the base or superclass. You can add or replace methods and data values from the parent class in the child class, and the child class can have one or multiple base classes. So in order for this lecture to work, I need to import the person class from the previous lecture. So I'm just going to run this block of code from the previous lecture. And then we can move into our inheritance example. So here we're creating a class called student, and this is derived from the parent class person. And within this dunder init function that we're replacing in student, we're initializing person using some of the variables that are passed into student. So now we'll have all of the data and methods of person, and then we're doing some additional things. So in this case, we're setting self.gpa based on this new variable grade point average. We're also slightly changing up how str works. Under str, it's largely the same, but we're adding in the GPA to the output. So then we can initialize this with student and then the variables. So it's much the same as the previous lecture, except we're adding in the GPA here. So the first name is Alice, last name is Python coder, year of birth is 2001, and she has a stellar GPA of 4.0. So if we print S now, we're printing the string representation, which includes GPA. But you'll notice that we can still do things like call s.approximateAge. And approximate age isn't defined anywhere in this class definition, but because we're basing this class on person, we can still use things from person unless we replace them explicitly. So we have all of the things from person, except we're replacing how init works and how str works. Now there are other uses for inheritance as well. So for example, you might want to use some objects from the Python standard library that you can change up a little bit to work well for your particular situation. Or, as I mentioned in the lecture on exceptions, you can create your own custom exceptions by deriving them from the exception class. And so in this case, we're just creating an exception called myException. And so when we run this and we raise myException, you can see that we get myException, something bad happened, here's some information to help you sort it out. So this is a very powerful construct, and it lets you tweak how Python works by creating your own subclass from existing classes. So we have an exercise here on classes and inheritance. We want to create a class named dog that represents dogs. It should take the dog's name, and it should have another method called speak, which should return some dog appropriate sound like arf. So our task is to create several instances of this dog class and iterate through the list, printing each dog's name and the sound they return. And then we want to create a poodle class from dog, and that should have a more poodle appropriate sound like yip when you call the speak method. And then we will add some instances of the poodle class to your list of dogs. So it contains some dog instances and some poodle instances, and rerun the code. So I'm going to go ahead and work on this. Again, please pause the video if you'd like time to work on this yourself. But I'm going to create class dog, which I'm going to base on object. I could optionally just leave this off and just have class dog, but I like to be explicit with this. I'm going to define dunder init, which will take self as a required argument. By convention, we call it self, and then it will take the dog's name. And we're going to say self.name equals name. So we're storing that within this instance. Okay, and then it will also have a method called speak. And we'll make this self as well. So this should return some dog appropriate sound, for example, arf, according to the instructions up here. So now we've created our dog class. And so we can say dogs equals maybe dog Max, dog Lucy. And then we can say for dog in dogs, print dog.name, and then dog.speak. Alright, so now we can see the dog's name and what the value returned from speak is. So now we want to create a class called Poodle, which is derived from dog. So I'll create class Poodle, and now instead of basing this on the generic object, I'm going to base this on dog. So we can say def init. We still want, well, actually I don't need to say def init, and the reason I don't need to say this is because all we're setting is name, and a dog will have a name and a poodle will have a name. So really I just want to inherit this from the parent class, and I can do that by just not defining it. And so that's saying I'm not replacing init from dog, but since this is based on dog, it will still have init from dog. And so I can really just replace speak, and I can say return yip. And so now let's say I change this to poodle. You can see that this works exactly the same way because both dog and poodle have dog.name, or the .name property, and the method .speak. But these have different implementations. So the speak method of poodle is different than the speak method of dog.